Hey guys, it's Mr. Lowry. I'm just going to walk you through the zero exponent property real quick. I couldn't find a video that I liked enough on the zero exponent property, so I just decided to make my own for you. The zero exponent property is pretty easy to remember, but sometimes it's confusing for students on why it works. So let me show you. The general rule is this. Anything to the zero power is equal to 1. So usually how that's represented is a to the zero power, where a can represent any real number, is equal to 1. Okay? So if you remember it, that's great. Some people think it's 0 though, because usually when we multiply by 0, we get 0. But we're not multiplying by 0, we're raising to the 0 power. Okay? Let me give you a couple quick examples, and then we will I'll show you why it works. Okay, so basic example. Okay, so if you have like 5 to the 0 power, that's 1. If you have 3 to the 0 power, that's 1. If you have x to the 0 power, that's 1. Right? Pretty basic. Okay, it can get a little bit more complicated. We'll do those more complicated ones in just a minute. We'll throw some different scenarios at you. Let's see why it works, okay? And this is going to go back to the quotient rule that we just talked about or that you just learned about in the previous video. Okay, so when you have two things that are the same base raised to the power, you subtract the exponents. Okay, so if I had x to the 5th over x squared, based on the last video, you would get x to the 3rd, right? You know that 5 minus 2 is 3. We get x to the 3rd. Okay, if we write it out, we can see that that's the case, because we can use our multiplicative inverse property and cancel this to get a 1 and cancel this to get a 1, and there's 3 x's left, and they're all multiplied. Okay, now think about this for a second. What if I had x to the 5th over x to the 5th? Okay, well, according to the quotient rule, I'm supposed to subtract the exponents, right? So 5 minus 5 would be 0. According to the quotient rule, I would get x to the 0 power. But you're like, well, what does that mean? Okay, well, let's write it out. So we write x times x times x times x. Right, there's x to the 5th. And then we got x times x times x times x times x on the bottom. And we start canceling stuff, right? Cancel, 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 cancel. And it kind of looks like there's nothing left. Except what we have to remember is every time we cancel in this way, we're using the multiplicative inverse property. And if we're using the multiplicative inverse property, we better get the multiplicative identity. Right? So this cancels and gives us a 1. 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 And this cancels and gives us 1. So we're left with the number 1. Okay? According to the quotient rule, x to the 5th over x to the 5th is x to the 0. According to like expansion and the multiplicative inverse property, I get 1. That means that these two things must be the same. Right? X to the 0 must be 1. Okay? Now just be careful. This doesn't mean that x to the 0 is the same thing as x to the 1. That is not what this is saying. This is saying that x to the 0 is the number 1. It's not a power of x, it's just the number 1. Okay? Let me give you one more justification, because this again is kind of weird. Let's look at some stuff, some powers of 2 here. Let's go 2 to the 3, and 2 to the 2, and 2 to the 1. Okay? 2 to the 3 equals 2 times 2 times 2. Which is equal to 8. 2 to the 2 equals 2 times 2, which is equal to 4. Okay, 2 to the 1 is just 2, right? Notice the pattern. Every time I'm going down a step, down a power, I'm dividing by 2, right? 8 divided by 2 is 4. 4 divided by 2 is 2. Okay, if I'm going to continue this pattern, I should do 2 divided by 2, right? And 2 divided by 2 is equal to 1. So continuing this pattern, 2 to the 0 has to be equal to 1. So again, that's just showing you that something to the 0 power is equal to 1. Okay? what I could do here, if I wanted to, is I could add an extra 1 in here, right? I could say this is times 1. 2 to the third is 2 times 2 times 2 times 1. It's still 8, right? 2 squared is 2 times 2 times 1, right? And then 2 to the 1 is 2 times 1, right? We get 2. So what's left over when we divide by 2, or when we have 3 2's and then 2 2's and then 1 2, there would be 0 2's here, but there's still a 1 because, again, 1 is our multiplicative identity. Okay? So anything to the 0 power is 1. Okay? Okay, let me give you a couple more examples that can be a little bit tricky. Okay, so let's do this. -4 to the 0 power. Okay? Notice that this whole thing is being taken to the 0 power, so this guy is 1. Okay, now what if I had this instead, though? -4 to the 0 power. Looks kind of similar, but in this case, the order of operations says that the exponent comes before this subtraction. And so really what's happening here is more something like this, although you don't usually write it like this, is we got 4 to the 0 power, and then at the end we make it negative. So 4 to the 0 power is 1, and then at the very end we make it negative. So this is actually -1. It's still true that anything to the 0 power is 1, but you got to remember, though, is this negative is not being raised to the 0 power. Okay? One more real quick. If I have, let's say, 3x to the 0 power, okay? This thing right here is being raised to the 0 power, right? So that means we get 1. This is just something raised to the 0 power. But if I have 3x to the 0 and I don't have this 3 in parentheses, this 3 is not being taken to the 0 power. This is just 3 times x to the 0, right? So this 3 is not getting taken to the 0 power. So the x to the 0 part is 1, but the 3 is still just a 3. So we get 3 times 1, which equals 3, okay? So what I said is still true. Anything to the 0 power is 1. That's correct. So why do we get a 3 out here? Because this guy is not being taken to the 0 power. The only thing being taken to the 0 power here is x. Let me write this a little bigger. So x to the 0 power, this is something to the 0 power. That is 1. This just so happens we have an extra 3 out here. Okay? So that's the zero exponent property for you. Explained a couple different ways. If you can remember it, it's not too complicated. However, the meaning behind it, or why, might be a little bit more complicated. So that should help you out and help you with your notes today. Thanks for watching.